The recording started. So yeah, we are group 106 of the MLOps assignment. These are group members. Vivek Kumar Singh, Ashit Kumar, Vikram S, and Adar Ahmed, and myself, Raghavendra. So let me just go through the GitHub repository. The assignment is predicting the art disease with a given data set that is containing 14 features of the patient's data. So this project implements an end-to-end MLOps pipeline for the art disease prediction, covering the data pre-processing, model training, experiment tracking, CACD, containerization, Kubernetes deployment, and monitoring. So this is a GitHub repository that we created. So let me show you in local device. So here in the source file we have the train.py. So we have already executed that. So once the train.py is executed, we have trained the model using the two models. One is logistic regression and one is random forest. And clearly we got a winner as a random forest as giving the high accuracy. So we have saved the random forest job as a job loop file. And this script, this train.py script trains logistic regression and random forest models using a unified pre-processing pipeline and saves the best model for deployment. So in this case, our best model is random forest. So the next thing is experiment tracking. So when I run the MLflow UA command, we are able to get the experiment tracking results here. So once I click on this, so once you click on this random forest, it will show all the accuracy, precision, recall, and ROC metrics, and it will show for the logistic regression also. To show the accuracy, precision, recall, and ROC for the logistic regression. This MLflow is used to track the experiments, metrics, and artifacts, enabling reproducibility and comparison across the models. So let's check the fast API model serving next. So I've served the model using the fast API, and I've started the application, and here I have checked the model with the example input, and it gives me the output as R disease risk is 1, which means R disease is present, and with the confidence of 70.5%. So this trained model is exposed to a REST API using fast API. It is providing predictions and confidence goes along with it. So the next one is Docker containerization. So you see the icon, the Docker is already running here, and as per the command prompt, I have created a Docker, which is where the build is completed, and I have started the Docker file also. So here I have again tested it with a sample input, and it gave me the RDCS 1 with the output with the RDCS as yes, and confidence as 70.5%. So this fast API service is containerized using Docker to ensure the portability and the reproducibility. So the next step is to deploy the model using the Kubernetes. So I've deployed the model using the Kubernetes and verified by getting the pods in it. It stores the status as running and ready 1 of 1, and we can see the services what it is using, and it's a node cluster IP, and here this Dockerized application is deployed to a local Kubernetes cluster using the Docker desktop and exposed via a node port service. So in this case, I tried out with an sample input, and it showed the same result as RDCS1 and confidence 70.5%, which gives the output. So next thing is monitoring and logging. Here we can see the status of the post and the get comments, and I've also introduced an API that shows the health of the model. So here you can see the status as healthy. So this basic monitoring is implemented using the structured logging and the health check endpoint to track the API availability and the performance. So the last thing is CA/CD. So once I get to the actions and selecting in any workflow, so here all these operations are running in the continuous integration and continuous deployment phase, along with the unit test, run linting, and install dependencies and everything. So this project demonstrates a complete MLOps workflow from model development to the production deployment, incorporating all the CI/CD, containerization, orchestration, and monitoring using the industry standard tools. Thank you.